May God bless you.
Bless you. So now the fundamental theorem, I don't know why they call it part 1 and part 2. Actually, I do know why they call it part 1 and part 2, but most of the time, it's part 2. When you go to use it in the real world, right? Now, they do some tricky things on the AP exams. Guys, I'm recording. They do some tricky things on the AP exam. Okay. But let me write it down and then I'll explain what it is. If I want to integrate a continuous curve from A to B, in other words, I want to find the area under the curve, f of x, with respect to x, well then that is equal to the antiderivative of b, evaluated at b, minus the antiderivative of a, I said it right, but let me explain what it means. So to find the area under the curve, you take the antiderivative, capital F, and evaluate it at b, the upper limit, and then you're going to take that same antiderivative and evaluate it at a and subtract a from b. All right? So that's really what you do. And there's a proof in the book, and we'll skip the proof for today. But let's just jump right in at example number 5. So now for example number 5, they want us to evaluate the area under the curve from -1 to 3 of the function x cubed plus 1 dx. Now, earlier we said that when you take the antiderivative of something, the antiderivative represents a family of functions. In other words, we don't know if it translates vertically, so we always put that plus c on. Well, here we don't need to do the plus c because we're evaluating, because we have a lower limit and an upper limit. So we would never do the plus c because we know exactly these points are going to be on the line, so to speak. So how would I do that? Well, first we need to figure out what the antiderivative is. So you want to think kind of, what do I take the derivative of to get x cubed plus 1? And so it's going to be x to the 4th, right? Because if I take the derivative of x to the 4th over 4, I toss the 4 to the front, the 4's will cancel, and then when I subtract 1, I'll get x to the 3rd. And then plus 1x, right? Is that right? If I take the derivative of 1x, I get 1. So now I just need to evaluate this from -1 to 3. Now it's always b minus a, so you don't have to write this down, but I will the first couple times. So what I'm going to do is this is equal to this evaluated at b minus the antiderivative evaluated at a. So I'm going to say 3 to the 4th power, 3 to the 4th power over 4 plus 1 times 3. Okay, minus. So what I did there, just in case you're wondering, is I'm evaluating f of b minus antiderivative capital F of a. So I'm plugging in the 3 for b. That's where this comes from. Just plugging in a 3 wherever there's an x. And then I'm going to do the same thing over here, minus this stuff. So I've got a -1 for a, so I'm going to have -1 raised to the 4th power all over 4 plus 1 times -1. So, well, I wrote that down out of place, out of turn. I probably should be a little more careful with that. So that's plus 1 times -1 and all that stuff. And I got to take the negative of that. So now in the next line, what's 3 to the 4th power? Is that 81?
Yeah.
So I've got 81 over 4 plus 3 minus, this is a positive 1 over 4 minus 1. I'm going to go old school here to flex my my mad skills of common denominators and whatnot. So this 3 becomes 12 over 4. So I've got 93 over 4 here, minus, this negative 1 becomes 4 over 4. 1 minus 4 is negative 3 over 4. But when you minus a minus, you actually add. And so I get 96 over 4. 4 goes, wait, does that go into that evenly? Is that 24?
Yes.
Is that what that is? Yeah, it's 24. Okay. So now what did I do? I found that the area under the curve of this function, x cubed plus 1, from negative 1 to 3 is 24. Now I can verify that 2 ways on my calculator. The first way is to come in and graph the function. So if I say x cubed, right, plus 1, and I graph that, this is my graph. It'll be a cubic with the y-intercept of 1. And what I want to do is I want to find the area under the curve, so I hit second trace, which brings up my calc menu, option number 7. Lower limit of negative 1, upper limit of 3. And sure enough, it's 24. That's one way to double check it. Another way to double check it is I could do if I hit the math catalog, this function integral, which is option number 9, if I were to plug in the function x cubed plus 1, comma, I'm going to evaluate with respect to x. My lower limit is negative 1, my upper limit is 3. Making sure I put a comma between everything, I think so. Should get 24, yep. Does that make sense? Any questions? No? Okay, good.